Good afternoon. It is the appointed time, so if someone would help us with closing the doors, we'll get started. Please remember to silence your phones. And as is required, let me read the statement about fire codes. In the event a fire alarm sounds, please remain in the auditorium and stay seated. Should there be a need to evacuate, a Springmore staff member will direct you on how to leave in an orderly fashion. Please remember not to use the elevators and go to a red pole once outside. Well, as we enter the holiday season, I wish for each of you a fulfilling and fruitful holiday. We have a few announcements here. Janet Carter, would you start off for us?
Good afternoon. I'm going to give you an update on our Employee Appreciation Fund. You're aware that we're collecting contributions to give a monetary gift to our staff.
Closer to the mic like eating ice cream cone.
Okay. You're aware that we're collecting funds to give to our staff for a holiday gift. As of this past Friday on the 10th, we've collected $36,405 so far. Our collection time runs through next Wednesday, the 22nd. That's a week from this coming Wednesday. So if you would like to participate and you have not done so yet, you have about 10 more days that the accounting department is able to accept contributions for that. You also should have received in your internal mailbox this weekend an invitation to our Employee Appreciation Reception where we'll distribute the checks to the staff. That's on December 7th. We do it in both South Village in the morning and North Village in the afternoon. We would love for you to come to one or both of those receptions. It's just a really fun time to get to greet the staff and speak with them personally. So we hope that you'll be able to attend. And as always, participation is voluntary and confidential too. So thank you.
Thank you, Janet. In the September meeting, we elected officers for the coming year. One of the people that we elected was Jack Gabby. Jack has experienced some health problems and has chosen to resign from the position of director. And following the guidelines of the bylaws, the executive committee was charged to selecting a replacement for him. So the executive committee has elected Tracy Hurley as the director. So Tracy, I saw you come in. Would you stand? Thank you. Look forward to working with you. Justin, you have an announcement.
Yeah, just have a few announcements from the chaplains. We have quite a few special events coming up in the coming weeks as the holidays are gearing up and coming into full swing. The first event is a grief group that will be a 5-week long grief group, and it begins tomorrow at 2 p.m. It'll be held in the chapel. You can sign up on the portal or just show up and come, and we'll be glad to have you. It'll be a time to just kind of to share and have a little extra support at this time of year, which can be a difficult season amidst all the joy. This Wednesday, also, we're having a regular monthly dementia support group, dementia caregiver support group, and it's held at 3 p.m. In room 279, right? 273. I always forget that last number. And so do come to that if you want to come to that. Next Wednesday morning at 10:30 here in the auditorium, we'll have a special Thanksgiving worship service focused on giving thanks, and we'll have communion, and it'll be a joyful time together. So please come to that if you can as well. And then on Wednesday, the 29th of November, we'll be starting a four-part Advent book study. We'll be using Will Willimon's book, Heaven and Earth, to shape our conversation and our preparation this Advent. So feel free to sign up or call, sign up on the portal or call. Let me know if you'd like me to order a book for you. Feel free to order one yourself as well if you'd like. But if you want me to order a book for you, let me know. And that book study will start on the 29th. Thank you.
Thank you, Justin. Brandon, you have comments for us today.
All right, good afternoon. Good to see everybody. I've been excited to hear about this, about the James Webb Telescope. Mr. Epps has been talking about this for a while, so I'm really excited to hear about it. So I won't take up too much of your time, but I did want to follow up on a memo that y'all all should have received over the weekend regarding Leah Willis and her not being able to return to Springmore. And I won't rehash all that. I think the memo says it all, and very sad she can't return. And I want to thank her for all of her time and effort and everything she's done here at Springmore. And again, we'll keep you all updated when we're able to celebrate all her years of service here to Springmore. So keep her in your thoughts and prayers, and so she continues to heal and get better. I did want to share something I think most of y'all will find positive. I found out late last week that that Brenda Baker is going to be able to come back and work with us temporarily until we find a permanent director. So, wow. All right, good. All right, good. I was hoping y'all'd like that. So that's great. I'll take that in for a second. So Brenda's she's gonna start tomorrow. Actually, she's gonna work part-time, 3 days a week, and she's going to get us through the holidays. She's going to get Pathways back on track. So that's all taken care of for January and February. And then when we do find the right candidate to fill the position, she's still going to stay on and actually train that person. So it's a temporary thing. Y'all know she's retired, but there's no like, I'm only going to give you a month or 2 months, We're going to wait till we find the right person and fill in. So anyway, I'm really excited. She'll be here tomorrow, and we'll go from there. So if y'all have any questions, let me know. And it's good to see everybody. So happy Monday.
Thank you, Brandon. I'd like to recognize Jim Epps to introduce our program. Thank you, Jim.
Yes, sir.
Are you waiting to hear from us?
Would you announce that again, please? Jim Epps is coming forward. Oh. Brenda, thank you. Well, I'm delighted to be here today to introduce our speaker, something I've been looking forward to all year long. This is my last program, so you can breathe a good sigh of relief. You won't have to hear me anymore up here. But Doug Lively spoke to my Rotary Club back, in the fall. Spring. In the spring. And I was so taken by his presentation, and I just felt like it was something that we would all enjoy here at Springmore. So I'm anticipating a great show, and I hope you enjoy it. Now, I told Doug I was not going to give him a big introduction because I didn't want to take his time, because he needs all the time we can give him. But this is what I am going to tell you about him. After graduation from North Carolina State University, Doug developed aerospace communication devices. What was that? Oh, I'm sorry. Okay, there you go. We had a son that went there too. Oh, by the way, Brandon, you had a call. You need to go to your office right away. You can't watch this. Okay, I'll start again. Give you another chance. After graduation from North Carolina State University, Doug developed aerospace communications devices. He has been an avid amateur astronomer since 1996, and also a member of the Raleigh Astronomy Club. Doug was awarded the title of Master Observer by the Astronomical League in 2021, and I think that's no small award. Doug is highly qualified to present this program today, and I could tell you more about that, but I'm not. So let's welcome Doug Lively to Springmore Resident Association. Doug, we're glad to have you here.
All right, Jim, thank you so much. I really appreciate that. I just want to say thank you to Springmore staff, to all of you, to Jim for setting this up. I'm really excited about doing this. Jim and we talked, I think it was back in April. I want to say it was April of this year. And since then, I was out in Montana. I've been a national park astronomer for the National Park Service for the last 2 years. And so we were kind of trading emails back and forth. And I think Jim was like, "Are you really going to make it out here?" But I did. And we finally did. My wife and I made it back and everything. And so super excited to be with you guys. I was really glad to see all the state people. How many people went to state and everything? All right. So I'm glad to see you guys. You know what you say to a state student in a three-piece suit? Will defendant please rise? That's why I'm not wearing my three-piece suit today. But I'm so glad to see y'all. One of the things that I belong to, as well as Raleigh Astronomy Club, is I'm also a NASA JPL Solar System Ambassador. And that is a volunteer program that was actually started a number of years ago so that we could kind of take the burden off of NASA scientists for delivering information. And so they would look for qualified people who could actually go out into the community and share information about what NASA is doing. Today's presentation came, a lot of it, in fact, most of it, the vast majority of it, came from the Space Science Telescope Institute, which is tasked with operating the James Webb Space Telescope. And so that's what we'll be talking about today. I should have, it looks like I have gone back. So we'll just talk. James Webb had to lift off. And I want to tell you, getting that bird off the ground was a difficult task. It cost us about $1 billion. It was 15 years overdue. But we finally got it off the ground almost 2 years ago this Christmas. Christmas morning, 2 years ago, I was running downstairs to see this thing lift off. Wasn't to open presents. I couldn't do that till much later. But yeah, so it finally made out. This picture that you see right here, this is actually the last visual image that we have of the telescope as it's leaving Earth. There aren't any cameras on it that look back at itself. There's everything looking forward into space and everything. And as it went out, it was all folded up like a giant origami, and it just unfolded and wound up in this place roughly 1 million miles behind Earth. So it's in the dark cold of space where the temperature is extremely cold, almost absolute zero, and it is literally orbiting around this crazy place called L2, and that's a special place in Earth's orbit with the sun where the gravity is actually canceled out with the sun, so there's very little energy required to move the telescope around. So we think we're going to have it for about 20 years. If everything works out, nothing slams into it, nothing breaks down. But that's about enough on the technical end of the telescope. I do want to kind of get to Webb's mission. We're going to talk about 4 aspects of his mission. That's about all I'm going to be able to squeeze into 45 minutes. So thank you, Jim, for giving me that time and everything. So we'll talk a little bit about the early universe. That was its primary mission was really to try to understand, kind of close that gap. When did our universe begin? When did first galaxies appear? Talk about how galaxies have evolved over time. We'll also talk about the life cycle of stars. Believe it or not, stars have a life cycle. There's a birth, And there is a death. There's a time when they actually pass on, and their material is used in the universe elsewhere. And then we're going to talk a little bit about some of the other worlds that we've looked at. All right, so let's get right into that. Okay, so seeking some of the first galaxies. One of the things we were concerned about with Webb is how deep is our universe? How old is it? And so there's a lot going around about how old it could be. And so part of this is as our universe begins to expand, light gets stretched out. And so the earliest galaxies are not in our visible view anymore. James Webb can actually help us see that. So, and as galaxies begin to evolve, this is where we're at now, highly evolved, highly organized. And as you go back in time, they actually become less organized into where they're almost literally spherical in shape. So the ones that are way back here. So that's what we expected to see. Now here's what we actually did see. So this is literally one of the first images that came back. Now this is a special photograph because this was a ton of galaxies in this picture. We had actually taken one with the Hubble Space Telescope once before. But but in this picture, we saw so many galaxies that as I understand it now, we still have not finished counting the number of galaxies that are in this photo. This is a very special. Let me just go back that way. So this is the Hubble image, and you see Hubble could not quite see. And the reason why we kind of blew this piece up here is Hubble could not see nearly or observe nearly as many structures in this. But over here, we began to see a lot more galaxies. Now, at this one we're pointing here, this is actually the oldest galaxy that we've come up with. This is actually called Maisie's Galaxy. And the reason why it's called Maisie's Galaxy is because one of the Hubble scientists was in his office looking at this very photo, trying to make sense of it, and his granddaughter walked in, and she said, "What is that red one?" And he hadn't seen that one yet. And her name was Maisie. So it's named Maisie's Galaxy. It turned out to be the oldest galaxy that we could actually observe. And the understanding is that it's really within about 480,000 years of Big Bang. So this would have been one of the first galaxies that actually emerged. So we're going to take a walk through what that might look like. So this is the evolution of galaxies. This is a recent image that came from, and video that came from the Space Telescope Science Institute. You see in this, as we're beginning to fly through, galaxies are all very well defined. Many of them are spiral, some of them are spherical, but most are spiral or double galaxies. And we are now flying through, and actually as we fly through, we're actually going back in time. We're actually looking further back into the universe. And you can see as we go, galaxies begin to look a little more irregular. They look redder. And then as we keep going, you'll see that they even become even more irregular looking in shape. Some of them are trying to become spirals, but not quite centered. But now we're getting more into those spherical looking galaxies. And that was it. That was our earliest galaxy. It ended a little soon, but that one is actually, that galaxy is, again, roughly about 480,000 years after Big Bang. So that's when we begin to see the first galaxies emerging and actually forming. All right, so let's move on. All right, so I'll talk a little bit about one of my interests actually in science and in astronomy, and that's when galaxies merge. Now we found that galaxies actually do attract one another, and they do merge. And when they merge, that's very good because a lot of times the mergers actually produce stars. And when you produce stars, you produce more planets. And when you produce more planets, more chances for life. So we see a lot of these stars. Now, some of you actually have seen this, I am quite sure, but you don't know quite what you're looking at yet. We're going to see this in just a minute. But this is known as Stephan's Quintet, and you can see it overhead. Even now in the fall, it's in the out between the constellation Perseus and Cassiopeia. And in this one, this is actually the Hubble image of Stephan's Quintet. These are actually a little more than 5 galaxies, although when Stephan, and I don't remember his last name, but when he discovered it, he could only see 5. But these galaxies are all merging. They're actually all passing into each other. And some of you may have heard that our own galaxy, the Milky Way, is going to merge with the galaxy of Andromeda in roughly about 5 billion years. The good news is none of us will be here. I don't know if that's good news or not. But in reality, galaxies are sparse structures, so that when they do come to one another. Now, I'm purposely not using the word collide, because the news media has used that word, and that is a sensational word. That's not exactly what's going to happen. Again, galaxies are very sparse, and it's kind of like your fingers kind of coming together, and they just kind of just move through one another. So it's not a collision. We're not going to run into each other. We're not going to have to call Allstate to fix our galaxy. So they will pass through one another, and we see galaxies merging in our universe and about. And so again, this is what's happening with Stephan's Quintet. Now, this is a Hubble image, and this is a JWST image. Okay. Now, as I said, and so you can see one of the things that JWST allows us to do is there's a lot of dust and a lot of brightness here that you can't really see through. And in this image, they become a lot more milky. And that's because the JWST is able to receive infrared light, and and that allows us to actually see through dust and through glare and things like that. So that's why we can actually see more structure. And one of the neat things that we look for are these red areas around here. And these red areas that you see here that you don't really see very well in the Hubble image, that's where star birth is happening. And again, when we talk about star birth, that also means planetary birth, because stars and planets are born together. So it's a wonderful, wonderful thing to think about. All right, so I told you you've seen this galaxy before, and I know you're saying, no, I haven't, but I'm saying, yes, you have. And so let's see. This is the image of that in 1946. And if anybody, how many here have seen It's a Wonderful Life? I certainly have. And this right here, if you remember, the angel comes in and goes, Joseph, Joseph. And he's got a problem down there on Earth with George Bailey. Well, this was the actual image that we used from Griffith's Observatory in 1946. And now this is the Hubble image. I kind of rotated, or I'm sorry, this is the JWST image. I kind of rotated it around so you could look at it. So you see, that is that galaxy. You've all seen it before. So go back and look at the very beginning of the movie again. One of my favorite Christmas stories, by the way. But so we have really come a long way. And I'll tell you, even for amateur astronomers like myself, there are, our technology has just really blossomed. So even the average person can make some amazing pictures now with just a rudimentary telescope. So it's wonderful the way that not only is this happening for scientists are able to see this kind of technology, also people like you and like me can actually purchase a telescope or something like that and actually give you maybe not that image, but something very close to it. And we'll see some of those in just a minute. All right, but here's the thing. Not all relationships in life work out. It's true here on Earth, and it's also true on the cosmos, and sometimes galaxies just don't get along. Now, we don't know why this is. Some galaxy mergers, like the one you just saw with Stephan's Quintet, are nice, it's tranquil, it's pastoral almost. And so things work out, we get new stars and new planets, but we have seen in the cosmos, and this is another JWST image, that when galaxies merge, they just fight like cats and dogs. And there's nothing you can do about it. And this is a case that we have here in this. There's a lot of violence going on in this photograph. And literally, there's a lot of destruction. So things are blowing up a lot, but it's not a beneficial explosion, not one that creates a star or one that actually will help you with planetary formation. Rather, this is literally destroying pieces of galaxies as they try to merge. So again, it's funny how, you know, in the cosmos we have relationships that don't work out so well, and so this is one of those cases. I'm going to show you another one. This one is called the Cartwheel Galaxy. This is a lot of amateurs do try to image this galaxy. This is actually one from Hubble, and this is one from JWST. Now, JWST is able to show us a lot more detail. So you can see all the detail you have here on the Cartwheel. But, you know, this galaxy just does not look right. You know, here he's got some galaxies around here that look a little nicer. They're nicely formed and everything. But this one actually encountered some type of impact that literally took away a lot of the dark matter that's in this galaxy. And so its spiral arms are literally flying out. And that's what we predicted would happen if there was no dark matter in a galaxy. You would have the degradation of spiral arms. And so this one doesn't have the nice spiral arms like you see over here. These are so much more balanced. So we don't know what happened. We don't know what impacted this galaxy. We just know that there was an impactor, and that one's you know, needs further study. There's another case where something didn't go very well in a galactic merger, and we're trying to understand what it is. Here's another one. These is one of my favorite groups. Now, these are not James Webb images, okay? And the reason why is that I've been actually looking for James Webb to study this relationship here, but they haven't released it yet. But this is known as Bode's Galaxy, and this is known as the Cigar Galaxy. Now, in this galaxy right here, Bode's is very healthy. You have these really nice spiral arms and everything. It's very pretty. You see that there are stars all around it and everything. See, it's a very healthy galaxy. It looks very nice. But just about 11.7, I think it is, light years away, there is the Cigar Galaxy. And the Cigar Galaxy is not very healthy. For one thing, it's got this rift in the middle. We call that a rift. That's because Bode's galaxy is pulling it apart. And there's another galaxy up here that's not seen. It's also working on pulling it apart. So this galaxy is not very happy. Things aren't going very well. You know, this is in this image, we don't see any stars. And we see quite a few here. The issue is that there are a lot of explosions happening in this galaxy. we've had a lot of supernova explosions. Supernova explosions are the most powerful explosions that we see in the universe, and so they're very disruptive. And if your planet is living near a supernova, pretty much when that goes off, it gets obliterated. So there's not a lot of health going on here. We have the central rift. There's also a pulsar, which is not on this. Now, I took these two images myself with an 11-inch telescope that was provided by the National Park Service. I'm sorry, this was a 20-inch plane wave that we actually took it off. But I took these myself from the Glacier National Park when I was there. And so again, it's one of the areas I like to study. Why is it that Bode's galaxy and this other little galaxy up here we don't see are pulling the Cigar Galaxy apart? Why is it that there's so much violence over here, yet there's a lot of tranquility over here? Nothing is happening over here. So this is an area for further study. There was a NASA paper about this that was actually published, I want to say it was probably, I think, in the June timeframe. And this is a subject of much debate. I mean, we definitely want things to go well with Andromeda when she comes by. So to understand why galaxies either pull one another apart or very docilely merge with each other, we just don't know why that is yet. So a topic for further study, and hopefully by this time next year we'll have some Webb images of these two galaxies. All All right, I'm going to go back just for a second. Let me just pause that. So I'll just kind of transition now into away from galaxies, and we'll talk about star death. And so when we have a supernova explosion or we have a nova, that's when stars have a tendency to pass away. So this is going to be an example that you see. This is an animation of star death. So stars go along. They're actually consuming fuel through a process that we call fusion. And they get to the point where they can no longer consume fuel, and they begin, they explode, basically. They collapse on themselves, and they explode. Now, how many of you guys, has anyone seen the movie Oppenheimer? That was a great movie. I know I lived through, I'm sure many of you actually lived through a lot of that. And so I know I did. I actually was living down in Florida, and especially one that was near and dear to my heart was I lived through the Cuban Missile Crisis there. And that was a very stressful time in my family's life, with the fear that we might be pounded at any moment by a nuclear explosion. Oppenheimer actually studied supernovas to understand how to create the first atomic bomb. So he was actually, and of course his team, they were the geniuses behind this, and they understood that when a star runs out of fuel, it's kind of like going down the highway. You put your car, you're driving, and you're going 70 miles an hour out on the belt line, and you throw it in reverse. Please don't do that. Please don't try this at home or on I-40. But it basically has a stroke, so to speak. It gets to a point where it can no longer fuse or it can no longer split atoms, and it has a stroke, and then it collapses in on itself, and then it explodes. So it's a supernova implosion and becomes a supernova explosion. And that's what happens in stars. Oppenheimer studied that. And he was the first one to say, you know what, we can use an implosion to create an atomic explosion, to create fission. And that was the key element to understanding how to build a nuclear device. So when you see the movie, that's really kind of when they're all talking about, they're around that kind of like almost like that soccer ball, and they're doing this in the movie. That's what they're actually experimenting with, was how they were actually going to create an implosion first to create nuclear fission. So that's what we saw, and it was Oppenheimer and Chandra and a few others who actually figured that process out. So glad they were on our team. All right, so that's how star death happens. But anyway, these shock waves go out. They start radiating out into the universe, or actually into your own galaxy. And any stars or planets or anything like that can literally just be destroyed, or they'll just literally be wiped out at this point. So it's very powerful. Now here's a JWST image. This is known as the Crab Nebula. It's known as also known to astronomers as M1 or Messier 1, and this was a supernova that actually occurred in 1024 A.D. So people in Europe and China and the rest of the world actually could see this. This was so bright they could actually see it during the day. And so we have actually Chinese astronomers writing about it. We actually have annals and histories from Europe, Eastern Europe, for people who actually were able to see it during the day. So it was really quite an explosion. And so when people began looking back into that area of the sky later on, again, Charles Messier was a French astronomer back 1750 or so, and he began looking at the night sky. He was actually looking for comets, and he saw these fuzzy objects that looked like comets, but they wouldn't move. And his first one, humbly, he named after himself, M1. So that was Messier, and then of course he named 110 objects after himself. I don't know, He's a humble guy. But this is a very interesting nebula, and it has, over 20 years, I've had some astronomer friends who've actually taken videos of the Crab Nebula over time, and you can literally see it change over a 20-year period. There's lots of changes. One of the really interesting things is this star that's kind of right here in the middle. So that's what happened to the star after it blew up, right? It turned into what we call a neutron star. All the atoms and everything and electrons and all that stuff were squeezed out of it into a very dense star called a neutron star, and it began spinning. And so when a neutron star spins and has a heavy magnetic field, we call that a pulsar. And that was actually first discovered by a female graduate student. Anyway, she discovered this, and then so it's still here, pulsing and creating lots of wind and light and everything. And because of that, we're actually able to see what's out here. But we've also discovered lots of elements in here. There's a lot of sulfur. And when you see here where the yellow is, there's actually a lot of sulfur along here. And where you see the red, there's a lot of hydrogen. So all that hydrogen, what happens when a star does die, things don't go to waste. It actually expands out into the universe, out into a galaxy, and they begin to collect in other places. And when they collect in other places, that's when they begin to build new stars. And we'll see a little bit more about this in just a moment. Here's another really interesting area. Sometimes when these neutron stars, they can collapse further, and when they collapse further, they can collapse into a black hole. So with Chandra, the Chandra X-ray Space Telescope, and the JWST, we were able to merge images. Now they know that there's a black hole right here that Chandra can see because black holes emit X-ray radiation. And then we also knew that there was kind of a bright disk. And so I don't know if you can see that very well. There's a little dot right there. It looks almost like a little circular disk. That's actually a black hole. So we can actually image black holes with the James Webb Space Telescope. Now, a few years ago, we had this really nice image of a black hole that was developed by a team, and that team basically took telescope images from all over the world and merged them into one to give us it was actually a radio telescope image of a black hole. But now, and that was before JWST was launched, but now with JWST, we can actually directly image and see black holes. So pretty interesting. All right, so sometimes, though, stars don't die like an amazing explosion like you saw. So the explosion that I showed on the Crab Nebula was a very large, massive star, one that was much larger than our own star. When you have a star that's about the size of our star is considered a relatively small star with respect to other stars in the galaxy and around the universe. So when our star, a planet or a sun or a star like our own sun runs out of energy, it doesn't explode. What it does is it just kind of turns into a red giant, and then after it gets to the red giant phase, it can no longer attract its outer shell to itself, and it kind of just expands out into space. And so this is what we call, it turns into a ring. And so this is actually the Ring Nebula. This is an image that I took this summer at Logan Pass, or at Glacier National Park, with an 11-inch telescope. So with a modest-sized telescope, this is what astronomers can get nowadays. This is actually the Hubble image of that expanding ring here. And then this is the image that we get from the JWST. Now, JWST has a lot more detail. This image here is not a lot different, maybe a little bigger. Maybe we can see a little more blue in the center. With the Hubble telescope, the Hubble telescope has a 10-foot mirror. This telescope that I took this with only has an 11-inch mirror. It's only about like that. So there's not a lot of difference between these two images. But with the James Webb, which has an 18-foot mirror, and is out in the cold of space and looking at infrared, we can see so much more detail. And so I was actually in a meeting with Space Science Telescope Institute last week, and they're actually saying that, see these striations that you see kind of coming off the edges here? They're actually seeing new molecular formation happening in this. So they're actually able to detect the molecules. Some of them are hydrocarbons, so building blocks for life. So as this ring continues to expand out, it will be collected in another place within our galaxy and will actually then turn into new stars and new planets. All right, so let's talk a little bit about star birth. So when those supernova remnants and nova remnants are collected, they come to areas of space and they begin to are attracted to one another, and they begin to spin. And when they spin, they get more and more mass until suddenly we have what's known as fusion flash, and a star is born. And all this material that you see right around here becomes collected into what we call a planetary nebula, and planets, they kind of attract one another, and planets are formed out of that. All right. Now, there are a lot of places in our own galaxy that we see this happening. Our galaxy is a very healthy galaxy. We have a lot of hydrogen in our galaxy. We have a lot of dust, and a lot of that stuff gets together, and it actually creates new planets. Now, this is called the Carina Nebula. It's a very large nebula, but unfortunately, it's down under. So we actually don't get to see this, but you can actually see this at night from Australia. This is called the Carina Wall, and inside this wall, there's lots of new stars being born from all this dust. Just in that nebular ring that you just saw in that animation, they form just like that. A little closer to home, how many know what this is? This is one of the most famous. This is the Orion Nebula. We can see this actually right now, overnight, overhead at night. This is actually in the northern hemisphere. Orion's rising in the east, or roughly around 10 o'clock. Give it another month or so, it'll be up at around 9 o'clock. So it's easy, you can just walk outside and have a look at it. It's one of my favorite objects to look at. Now, this is a constellation Orion here. This is Orion's belt. And just down from Orion's belt, you can literally see this. There's actually 3 stars there. And that forms the scabbard for his sword. And right here in the middle, it's not a star at all. It's this, the Orion Nebula. Now, I actually took this picture myself. This is not a Hubble image. This is actually a Doug Lively image. I took this with my own personal telescope. And so it's again, this is a lot of astronomers take this image every year, and it's really beautiful. I can never get enough time looking at it. But I do want to show this star right here. Right in here, this is a structure that we call Orion Wall. And so that's this star right here. Now, this is a JWST picture. And just over, which in that kind of washed out part right there, is this star right here. And this star, you can see like a little wall right here around it. And there's a lot of star forming activity here. Now, there's another structure in Orion Nebula called the trapezium that also has a lot of star-forming activity in it. The Orion complex is really rich in star formation. It's so rich that we have stars forming here. We have other materials here that we know have the building blocks of life. We also have some other star-forming activity here, and right here, which is really kind of neat. It's in this little, looks almost like a little teardrop. This is what we call a stellar cocoon. And this little stellar cocoon contains that planet, what we call a protoplanetary disk. And this is an actual image. This is not an artist's concept. This is an actual image of an area where not only stars are forming, but planets as well. And when those stars form, and they finally become what we call stars, they blow open that cocoon and they start sending material out. And so that's literally when a solar system is born. Here's another close-up of that. I'm not going to explain each one of these, but right down in here, that is that protoplanetary disk that we see. And we've also been able to look at this and find that there are actually building blocks of life in that structure. And these are not ours concepts. These are actual pictures of star-forming material actually actually very close to us, just only a few hundred light years away. All right, here's another star-forming area. This is called the Eagle Nebula. Again, I took this one myself at Glacier National Park. And so this is actually from the parking lot at Apgar Visitor Center. But this is what you get to see when you get to have a really nice big space telescope. Here's the Hubble image of that very same image. You can maybe can make it out right here. And that's what we were looking at right there. This is called the Pillars of Creation. It's one of the famous nebulas that Hubble took a picture of. But when we look at it with JWST, we're actually able to peer through all this dust. And what do we see behind that dust? Stars. Lots and lots of stars. So these areas where we have all this molecular hydrogen and dust and stuff like that actually create stars. And these are star-forming regions. Here's another example from Hubble. I'm sorry, from JWST. These are in different wavelengths of light. And okay, and now we're going to have another little video where we're going to actually look at another star-forming region. This is in what we call Rho Ophiuchus. It's one of the star-forming regions of our galaxy. These are all JWST images that you're looking at now. And this is an incredibly beautiful one. This is more of a early springtime object. A lot of our astronomers in Raleigh Astronomy Club have imaged this. Now this is just an incredible complex. Here we have a star that's just been born, and what it's done is, remember that star cocoon I was talking about, and we saw the little image? Well, now we have a much, much bigger image, and this little star right here has actually blown open the star cocoon. And so it's literally ripped it open like that. And so when it does that, then it's literally kind of like a chick coming from an egg. It literally kind of has broken open the egg, and it's going to be moving out and away from it very soon. And then, but you have all this complex here where you see all this red. That's where all the hydrogen is that we use to make stars. Now, kind of an interesting thing that they saw, if you look at this star right here, you see these black jets coming out of it like that. And they've determined that what's in there are two stars, twins, that were born at once. And so a lot of stars are that. And I have some other close-up pictures. I didn't bring them with me, but when they look at this in close-up, there's actually many other areas where they actually have stars that are born as binary stars. In fact, most stars in the night sky are binary stars. Our star is unusual because it doesn't have a binary. So, all right, and then this is kind of like when we start talking about other planets, we're looking at, this is actually another artist concept of what a star cocoon might look like. So you'd have the central star in here, and around it you'd have planets forming in different ways. So, all right, one of the things that Hubble has actually done is that this star, it was actually able to image a planet that was going around it. So this is an actual image of a planet that's not part of our solar system. We call that an exosolar planet. So this is right here. We've never been able to see this before. This is the first that JWST has been able to bring to us. Not far from us is a system called the TRAPPIST system. We think that this might be one of the systems that is most likely to carry life. This is just an illustration, but the three central worlds right here, and they kind of show a little like water here, is that these three central worlds are actually in a place where liquid water can exist on the surface. Now, when we look for planets that are in what we call the habitable zone, and the habitable zone is very easily defined as that place where liquid water can exist on the surface. So if this summer, if you've been out to a local lake, a pond, or in a swimming pool, water is existing without you having to do anything special to it. But if you're in a place like, say, like Venus, all the water is boiled up into the upper atmosphere, so it's steam, or the water outside, say like on a place like Enceladus or on Europa or Ganymede, it's all frozen. So this is a very interesting place. They think that this might be one of the best places that we can actually look for life. Haven't gotten any signals back yet. Hopefully we will, but this is one of the really interesting places to look for. We do kind of, and I'm just going to show this very briefly, we do kind of resort to signals coming from these planets. These signals tell us, at least the ones that we have received, that it's got a lot of water in the upper atmosphere. So that's very encouraging. All right, and then closer to home, we're actually able to look at our own planet. One of the really interesting things that they discovered about Jupiter. Now, we already knew that Jupiter had a ring system. We discovered that back with Voyager, way back in the 1970s. But one of the neat things is that these are aurora. So if you ever seen, how many of you guys have ever seen Northern Lights? Yeah. I have. I got to see some this summer, and then actually over here in Cary back in 2003, we had a massive burst that came from the sun, and we were actually able to see northern lights at night. So it was really neat. Now, we are coming up on solar maximum, which means we do have a possibility we could see them again here in North Carolina. And if you want to track that, you can go to a website called spaceweather.com. And that's a really great, it's free, it's run by NASA, and they'll tell you if you'll be able to see northern lights down in our area. So you can look at that every day, and you'll get some really nice information from that. But anyway, we discovered that not only does Jupiter have northern lights, but they shine way out from the planet. So it's really interesting looking at Jupiter. Another hot topic these days is Mars. Of course, we know Elon wants to go to Mars. I personally don't want to go there. I actually talked to a NASA scientist about this a few weeks ago, actually before I went to Glacier, and he said, well, one of the problems with going to Mars is that by the time you get there, your body's going to liquefy. So Elon hasn't solved that problem yet. So once we do, then I guess we'll be going, but I'm going to hold off on that one for just a little bit longer. I don't want to, I'm already having enough problems turning into a blob as it is, but I don't want to be a real one when I get there. But anyway, one of the really neat things that we discovered about Mars is Mars does have irregular heat in it. It is heating. We think that the core is somewhat active still, which is actually good news for Mars. But the neat thing that we found in the signal data was water actually in the atmosphere. And we didn't know that there was water in the atmosphere. So that's one of the really cool things that we discovered about Mars. All right, so that's really kind of the end of my presentation. So I thought I'd just have some time for questions. Now, Jim has volunteered to be the roving microphone. Be nice to him. And I'll take any questions. I will tell you, if I don't know the answer, I'm just going to tell you, I don't know.
You can hear me from here. I want to know about James Webb, and I've heard that he's from Granville County, North Carolina.
So we actually have in our audience an expert on James Webb, Charlie. Always he's giving me this symbol. So yeah, just correct me if I'm wrong. As I understood, he's from Oxford, over in Oxford. So he was a director at NASA, and we certainly here in North Carolina are certainly honored to have such a great name out there floating a million miles away from Earth and sending back all these wonderful pictures.
Why was it named for him?
What's that?
Why was it named for him? Why was it named for him?
I don't know the process that actually drove that. I just know that as a former director of NASA, he did a lot to grow the organization. I think that they chose that in his honor, but I don't really know any more about that. Yeah.
I think he was head of NASA when we first got people off the planet.
Yeah. If you didn't hear Charlie, it was that he first was with NASA when we were actually able to successfully launch astronauts into space. All right. Wait for Jim to get around. You're going to get your exercise today, Jim.
Put on my jets.
When the Webb telescope is out there, do you have any control over it, or is it just gathering more and more information that you can observe?
Yeah, that's a great question. Let me see if I can. I think I've got a couple of pictures of the. Thought I had like an old picture of it, but anyway, the telescope does have attitude control. Now it's about 1 million miles away from Earth. It takes light about 6 to 9 seconds to go between the telescope and Earth. So we do communicate with it regularly. It does have, we hear a lot today about artificial intelligence. Well, NASA was really one of the first places and first entities to put artificial intelligence to work in their spacecraft. Because you can imagine sending a spacecraft way out into space, and all of a sudden there's a rock in front of it. It's got to move very quickly, and by the time you send a signal back to Earth and we respond to it, if the guy's awake at the console or whatever, you could actually run into the rock. So a long, long time ago, NASA put intelligence into its avionics. So while it's out there, the Space Telescope's kind of it actually looks at the stars that are around it. It feeds that into a computer, and the artificial intelligence in the scope makes proper attitude adjustments so that it won't, so it'll stay on course and won't veer off. However, we do have people who monitor it regularly. Again, about 6 to 9 seconds away is not so much of a difference that you can actually make a correction, actually ask it to do something. But I will say that one of the great things about when we actually did the orbital insertion around this crazy place called L2 out there, it was so good that they really think that they will have enough energy in the scope to actually have it last for 20 years. So it's pretty sparse out there. Although I will tell you that we have had one impact, at least that I know about, on the scope itself. Actually hit one of the mirrors. We had a rock that hit it, and so there actually is a little pit in one of the mirrors. But you won't see that on a photograph because by the time it all gets focused in and everything, that it's focused out. You won't see it. But yeah. All right. Good question though.
Other questions?
Anybody else?
What is the opinion of astronomers concerning UFOs?
You would ask that question, wouldn't you? So, of course, it's the acronyms, unidentified flying object, and so some of them are unidentified. Now, I've been doing this for about 26 years now, and so when you're out there at night, you really get trained to look at what's happening in the night sky. Now, one of the things that happens to us is that when we're out in darkness, see, today in this room, we have a set of structures in our eyes called rods and cones. Cones for color, they're all kind of centered in the center of your eye, and rods that are centered around the outside of your eye, inside your eye. So when it gets dark, unfortunately, the cones begin to shut down. So all you have is these outside pieces, your cones, that are actually able to see objects. So your vision and your ability to perceive is cut way down. So things like aircraft, weather balloons, believe me, they really do look like something when they're out there. Until you actually put your scope on them and you go, oh yeah, that's a weather balloon. It's actually happened to a couple of our astronomers. They were looking at something that they couldn't explain. And they say, they were getting ready, they were already set up, and so they slew the scope around to it. And sure enough, it was a weather balloon. A weather balloon at night can look very different. And it's also very difficult for you to understand if the object is coming towards you, moving away from you, especially if it's right in your line of sight. Now, what does NASA think about it, and what do astronomers think about say, maybe unidentified aircraft, UAVs that might actually be from another planet? Man, I'd love to see one. I would be famous. And I get speaking engagements at lots of places. But so far we really haven't discovered any. I know that I have really, with a lot of interest, watched some of the stuff that's coming out of the congressional reports and stuff. And right now, I mean, we still have a handful of objects that we really can't explain, and maybe they are from another place. I'll tell you for myself, my own perspective, we did have one object that I think was really key, and that is a few years ago we had this large asteroid pass by Earth called Amaro Maro. And it's so interesting that we even have some Harvard astronomers saying, yeah, we think that was an extraterrestrial craft. And the reason why is that it didn't act like any other rock or anything that we see in space. When objects enter our solar system, they kind of come in and they align themselves with our orbital plane. And so when they do that, they either get blown out of our solar system through gravity, they get blown into another planet, or they get sent around the sun where they actually crash into the sun. And if they make it around the sun, then you've got Mercury, Venus, and our moon to contend with. So very few things ever really make it to Earth, but they do occasionally. Well, what was interesting about Oumuamua is that it actually came in from the top of our solar system. And it came in, and then it did this really crazy thing. It aligned itself with Earth, and it used Earth's gravity to speed up and go out of our solar system. Now, I got to tell you, if that was coincidence, there were a lot of events that were happening to make that coincidental. So, again, a lot of people think that could have been one of our first real instances of an unidentified object that could have been from an intelligent origin. So I'm certainly, our universe is, and especially just even our our galaxy. Our galaxy has roughly about 400 billion stars in it. To date, we've discovered roughly about 5,600 exosolar planets and about 3,600 exosolar solar systems. So eventually, we're going to find somebody who wants to talk to us. Right now, nobody's talking back. I do give another talk about the Fermi paradox, why ET can't phone home. So we talk a little bit about the possibility of alien life and why they're not there. So maybe I can give that talk at some other time to you guys. But yeah, it's a great question. I think most of what we're seeing are explainable objects. There are a few that are not explainable. That doesn't mean that they are necessarily intelligent craft. I do think that there definitely, our galaxy is large enough to contain intelligent civilizations. Maybe the reason why they're not contacting us is because they are intelligent civilizations. So maybe they put a no-fly zone around the Earth. Who knows? All right.
Well, maybe that's a good place to stop
that's a
where
good place
people
to
are
transition
laughing.
off. All right.
Doug,
Thank you so much.
listen, stay here. I think you can see that people really did enjoy this, and we want to give you something for you to remember being here. Now, don't touch it yet, because I need to tell you about it.
Okay.
But this says Doug Lively, the James Webb Space Telescope, a presentation at Springmore Life Care Center, Monday, November 13th, 2023. Now, I found out that this material came from space and that it may be worth a lot of money. So yeah, we would like for you to keep it rather than trying to sell it, okay? Thank you so much.
Jim,
Thank you for being here. Hey, the next vice president is Jim Bundy, and maybe that he will ask you to come back and follow up with this.
well, I hope you will, and thank you guys so much. This is really cool, and thank you. This is so nice of you guys.
Well, thank you for doing this for nothing.
Well, it's my pleasure, man.
Yes, sir.
My pleasure. Thank you so much.
Thank you.
Let me say one other thing, Mr. President. Today, I had hoped to recognize a lady who's very important to us. She's the lady who presents us with our prizes that you're getting ready to receive. And she is the person who runs the bank. And when I can find her, she is still in bad health. And when I can find her, I will give her a recognition. Yes, ma'am?
She was here for 2 hours.
2 hours a day after.
Yeah, and I understand that she was not able to stay and be with us. So, but anyway, stop by the bank sometime and just give her a pat on the back and thank her. She pays for these things herself, and she wants to do it. So, thank you.
Thank you. I'll take this. Thank you. I've got one more thing to say. Jim, thank you not only for the day's program, but for the programs for the whole year. So let's give Jim a hand. We have door prizes, and if I could get you to draw a ticket. The number is 777-427.
Anybody? Here we go. Give him a hand. Congratulations. 777-427.
And the next winner is 1480793.
Somebody has it.
Over there,
Where?
well,
Read it again.
1840793. Yes.
I believe you have it. Four 480793.
So, yes.
Congratulations. Let's give her a hand.
Thank you all for being here. I wish you all a very happy
No.
holiday.
Don't let them go quite yet. One other thing. John, would you come forward, please? I have something for John. This reads, John Robinson for being the most creative poster maker on Sawmill Road, presented by Springmore Life Care Center. Thank you, John, so much.
Thank you, sir.
I'm through.
Okay. Thank you all for being here. I wish you all a happy holiday, whether your light comes from the Star of Bethlehem or the Star of David or directly from the source of light. We wish you a well-lit holiday. Goodbye. We're adjourned.